So I'd like to talk about causality, and I'll be trying to, first of all, tell you more about what an ontology is. It's a sort of theory of what exists, and I'll talk about that, in a sense, from the viewpoint of a sociologist. But really, that would also encompass work that's done in political economy or political science, politics, development studies, anthropology. It's really broader than just sociology. But it would be consistent with what's happening in those disciplines broadly. Oh. So I'll give you first my overall argument in the talk, and this is already being published in various places because I've been working on realist methodology for some time. So, for example, I have an edited volume, and it's the first chapter of that realist methodology book. It puts forward similar sorts of arguments, but in this talk, I'm really focusing very particularly on aspects of causality. So first of all, treating causality carefully would not be treating it deterministically. But a lot of people aren't sure what to do if it's not deterministic. They might just think, well, then it's probabilistic. But there are some other alternatives. And it involves reference to the world. So a realist thinks the real world exists. We make reference to it. And the world, especially the society and nature, can be seen as having layers. And the layers are not strictly in the multi-level nested structure. They're interwoven. And within that, I'll be talking in the middle of my talk about necessary and sufficient causality. So you might say a condition in this layer is a necessary condition in order for that to happen. And we usually call that contextual enabling. So contextual enabling and disabling factors might be called structural factors. And I'll conclude the talk by reviewing what structural factors are and encouraging people to think about structures and not just agents. And so overall, the analysis of real causes tends to invoke a depth ontology, and it links up with complexity, and it links up with a particular method of research which involves iteration. So the example of frailty in the earlier talk was a really good example that coming to the end of one study, the researchers think, oh, but there's some reason why these results appear the way they do. And they go and they ask why, find out why. Oh, the reason is some selection on frailty that wasn't in the data. And then next time they're going to improve the data to pick up that. So that would be iterating from the review and data into theory and then back to the real world to get some more data. So it's a very overarching approach to research. It isn't just about how one study is done, but how perhaps a whole series of studies are done, or how teamwork is done. And I'm going to give some examples. So one of the examples is from my own research, and the number of cases is very small. It's restricted to 205 because that's about how many countries there are. So then when you have your sample of countries, it's not a random sample. And that's a typical situation in business schools, in sociology, with, say, cases of people who are very difficult to get access to. It's not, the point isn't to have a random sample, but to talk sensibly about the sample that you do have. That is your population. So I'll talk about that. And here, at this point, I'll just introduce this concept of ontology in a little detail. So the ontological assumption of national level development policy is actually questionable. It seems obvious that benefits regimes and policy regimes are at the level of the nation. But actually, there's also the EU, and there's also the UN. There are also regional groupings and sub-regional differentiation. So actually, it's a bit ideological to use the concept of country so strongly in research and characterize Argentina as export-led, or, you know, and this idea of ideology has two meanings, which are really widely accepted in social sciences. The first meaning is an ideology is a set of beliefs, a normative set of beliefs, and that's the sort of obvious one. But the less obvious usage of the word ideology is that our terms of description, so describing Argentina as its set of policy regimes, that has implications for the world, has impact on the world. And here, in particular, the ideology or the choice of the names of the things and characteristics actually may be masking some other important aspect. So your ontological choices are your choice of terminology, and hence choice of variables, but choice of terminology, and it has a lot of implications for your reader, for users, for policymakers, and for the analysis. And so in iteration, you could actually stop and say, well, let's try and revise the wording and the categorization, and we'll get something better. And it's just different, it's just new and different. So this research is rather creative. So we did this with poverty and inequality and growth, and I'll be talking about this example to try and just quickly illustrate the findings from the more qualitative school. The school that I want to specifically refer to is a method school. It's the method of QCA. QCA stands for Qualitative Comparative Analysis, and it's a way of studying causality in a very simple data table of binary or ordinal data. And it's mainly used in comparative research. So this question of the country is very important. And it can be used in case study comparative methods. So you might have 50 or 700 court cases, and you could apply QCA. There are thousands of QCA studies published, and a sample of recent ones is in the notes pages of this presentation. And QCA can discern necessary causality, where X is necessary for Y, as well as sufficient causality, which is really quite different. And the main purpose of my visuals today is to illustrate the differences between necessary and sufficient causality. In this study that we conducted with the country data, we had the multinational data. We only had 84 of the countries with the complete set of relevant data. And there's a lot of statistical research about this. And so we used it, we reviewed it, we contributed to it. I did some growth modeling and some poverty modeling. And here, you usually have a deductive approach. But QCA is very different from deduction. So I'm just offering this contrast for you. Because it's really problematic to have the whole population in the sample of 84 and then say that you're doing a deduction to the population of countries. It's not a random sample. So why would we have confidence intervals? What's really interesting is actually the model. And we need to pay a lot of attention to what the models are. So the reasoning actually serves a different social function. The reasoning in the statistical, there's a huge number of studies. One man came here recently, and he said the World Bank has 80 economists working on this topic, and it was a multinational study of the relationship between some labor market policy and 80 people, full-time. And it gives credibility and authoritativeness to some of the statements that they make. And certainly if you were working in the UN or the World Bank, you'd want credibility. But that's achieved at the loss of realizing that statistical inference wouldn't be an appropriate thing to do, really. And they do statistical inference. But they do use interaction factors sometimes, and that's actually more like QCA. So QCA is more like bringing the contextual factors forward and realizing the great heterogeneity of the cases. So we conducted analysis of the same data using fuzzy sets and crisp sets, and I'm going to be showing you in a minute what that means. We found you could make a very good model of growth rates. So growth rates of countries kind of behave in a homogeneous way in response to investment. But you couldn't make a very good international model of inequality or of poverty reduction. And we were trying, because the typical claim is higher growth would lead to poverty reduction. So we really very focused on that issue and did several different models and linked them all together. But I haven't got space here to tell you the whole story. But it was from fuzzy sets that we could show that growth doesn't cause a reduction in poverty rates. And that controverts the standard World Bank story, which for many years was that growth will reduce poverty for everybody. We used the poorest quintile of each country, looked at the change in their income from 1972 to 2002. But what we did find is if you use the panel data model, I think I've got some results there. There's a couple of significant coefficients in an international model of growth. You can find out that investment increases growth and educational attainment increases growth. Very standard findings for that. But you can't get good results for something like poverty reduction. So I return here to what the fuzzy set analysis could tell us. Fuzzy sets, which are more like variables that are of an ordinal level of measurement rather than cardinal. And if we have cardinal data, we can just simplify it into a simpler set of rankings, say about 7 rankings, or 100 percentiles. That would be a fuzzy set. And we found that there was some other things going on in the pattern of poverty reduction. Like if you bring a lot of women into the labor market, and that increases labor force participation, and that increases if the skill level of those people also increases, then we have better poverty reduction outcomes. But gosh, there weren't very many countries that did that. But if there are 3 or 4, it's interesting. You see, QCA will look at these deviant cases, and if there's a little group of such things, we say, oh, isn't that interesting? It's real. It's real. And it's not error, and it certainly isn't outliers. These are important cases to look at. So we could show that growth also is not sufficient for the reduction of poverty. And I find it quite interesting. But what I'm focusing on now is really displaying some of the ways that this kind of work is done. where you get new findings from a new method. And this diagram shows women's labour force participation horizontally and the overall economic activity rate. That's the overall percentage of people in the labour force vertically. And if I just chose this diagram from all the bivariate scattergrams to show you that country data follow a very clear pattern of necessary causality here, that X is necessary for Y to reach any sort of high level. You can't reach the high levels on the left because of a constraint in the X variable. And this is a diagram that illustrates necessary causality. This argument might be familiar to you. It should really be taught to students even in statistics, but we don't really have typical statistical methods of discerning this triangle, this triangular pattern. And it turns out that the white triangle at the top left is the area of sufficiency. If X were sufficient for Y to occur over this space of X and Y, then you would have a lot of dots in the top left. And in statistical work, we usually look for both necessary and sufficient causes. So we really only look along the diagonal line, and everything else is called error. But here, these points are very interesting and suggest that X is necessary for Y by offering a contrast to these, and especially offering a contrast to those. So the whole range of data is very interesting. And fuzzy set analysis takes this kind of image, and it can handle multidimensional vectors. And it does that through a Boolean logic. So now X and Y can be multidimensional, and we could perhaps have a clear pattern where some combination of context and current conditions and events is sufficient for, well, say, an improvement in well-being. So I'm just showing you these images to try and illustrate how fuzzy set causality would work. Now I'm going to show the same pattern, but with crisp sets. So this would be where there's variables which are just either treatment or non-treatment, in other words, binary variables. Because the method of QCA can be used very widely. And as my talk continues, I'm going to refer to several applications in about 3 other areas. I'm sure you're not that interested in growth debates. So I chose to take examples from the study of homicide, and the study of irrigation, and the study of labor markets. I'll just be very brief in the actual examples. But the point is that there are 2 patterns in this 1, 0, 1, 0 XY diagram. So this is 2 binary variables graphed against each other. And the number of cases we could show, somehow we could find a way to perhaps have a big dot if there's a lot of cases. And this image is showing none there, some and many. And if that was the pattern of the outcomes, then you would claim that for those cases, without being probabilistic about it, there's a necessary cause. X appears to be necessary for Y, but not sufficient for Y. If it was sufficient, then these cases would drop to 0, because whenever X occurred, the value goes up to 1, then Y would occur. But there might be some cases in which X hadn't occurred, and yet Y had occurred. But here there's none for necessity. So there are other ways of displaying this, like Venn diagrams. And there's several different pieces of software. So the notes pages tell you the names of the software packages which are free. This is actually so simple. And in philosophy of logic, it's so standard that it's all been done in Stata, in R, and in some freeware that's really easy to get hold of. But the difficulty is more ontological or theoretical, how to conceive of your project. So I'm going to show later an example that would actually show you how to set up a qualitative project. So this diagram is slightly different. Watch again. Go back. We have none, some, many, and forward. This is sufficiency, illustrated with many, some, none. Okay, so the pattern is different if X is actually sufficient for Y. And an example, an example is from one of the papers in the literature in Sociology. The rights obtained for homeless people in different cities in America are going to be more likely to be achieved over time if these 2 conditions exist. So the X vector here is 2 conditions happening together. One of them is structural, and one of them is something a group does for the homeless. If they do that, that's actually a necessary condition for getting rights. But the number of cases was only 17 for that study. And yet it's a seminal study. It's highly regarded because the knowledge they have about those 17 cases is very detailed, indeed ethnographic. But this creates a way to make a sophisticated, transparent summary of one of the findings of that study. So I'm really just presenting work that others have have developed, and I'm trying to stress that you need a depth ontology. So I'm going to just say a little bit more now about depth ontology. It might mean that you have the global situation, perhaps reflected in the UN. You would involve Europe, if Europe's a policy-making body that matters. You would have the country level, perhaps benefit systems are managed at that level, and regions and sectors. And it's not only geographic, it's also that you have the labour market as a sector and its management. You have culture and ethnicity and the groups that lead the cultures of ethnicity. Those groups are actually overlapping. They then become part of the context for what people do. So when I say layers, I don't just mean geographic. I mean sets or organizations, corporate bodies, which influence the players that are inside them. And these levels, in turn, can only exist by virtue of those constituent human parts. So we don't like to say that it's just nested. So there's a sort of interweaving. And this argument has been explored, actually, quite seriously, because you might think, well, so what if it's interwoven? But it does matter very much that the causality isn't just from structure, from the sort of basics about if you're from the northeast, you act that way, and upward into the individual. It also works the other way. And especially, we need to realize the important feedback effects in the way that a culture or a policy is affected by individuals. And as a result of that discussion, it's widely agreed that the agents and institutions and structures are not just nested. They're related in complex ways. And an expert can tell you about how they influence each other, and that's causal. So I'm not sure if I've given you a definition of causality yet. I thought I did on an early slide. A cause is a mechanism which tends to make an outcome occur. And with that definition, saying it tends to, that means under certain conditions. If they're taken for granted, then it always makes that occur, but under those taken for granted conditions. If they're contextual and vary, then we may say, well, it's causal, but it won't occur if if Z is not present. So that's the definition of causality as mechanisms. And they operate across the different parts of this ontology. So that's one way of looking at it. A different discipline might look at it differently, say in politics, depending on what your focus is. So these are results from a QCA study of countries, thank you. And the results have 5 rows for different sets of countries, little tiny sets of 5 and 4 and 3 and 10 countries, which behaved in a certain way. And from that, we're able to test, is there any factor which is necessary for poverty to be reduced? The answer to that in this case was no. And you're not only testing for individual factors, but for joint factors as well. And you can also test for whether there are any factors which are sufficient. And this is actually a table of sufficient causality. It's a good result, but it's not a very simple result. And in our paper, we discuss all 5 of those possibilities. And there are measures of how good this result is. Very different from in statistics. You have consistency as a measure of how good the result is within a group, and coverage as a measure of how good the result is within the whole of that population. And this diagram is just showing there's a trade-off between the two. So your descriptive decision, how you summarize things, depends partly on a subjective decision about do you want really high coverage and then your fit is worse, or do you want a good fit and then your coverage is worse? And some countries would be left out. Some cases might be unique. So in the literature, which is really led by Charles Reagan and Benoit Liu and David Byrne, there's a number of authors, they explain how to reduce the truth table. And I just wanted to illustrate how the data would look for such a study. In this case, instead of using the international data, I'm going to use a study of irrigation. So irrigation, water flowing through a canal, the outcome is having a lot of water left for the people at the bottom of that canal, and that's a binary variable here. And the paper by Lam and Ostrom. Ostrom is actually a Nobel Prize winner in economics, you might have heard. And some economists who do a lot of modeling were actually making fun of her in the web, in blogs, when she won this prize, because they felt that this wasn't a serious method. You know, so to illustrate the kind of typical method that she would use and QCA would use, there's 19 cases of canal systems, and for each case, a lot of detailed qualitative evidence is gathered. And then for each of those, the presence of 5 different factors is summarized, either they're present or absent. Some are structural and some are incidental or events that have happened. And then the outcome is the water. And then this is analyzed, and the coding here is that a capital letter means the presence of a condition, and a small letter the absence. So then you get the results, and the way they present it looks like a model. It's not a statistical model, it's Boolean. So W occurs if either ACR, well, this is the overall possible model, and this is the reduced model. So the software just does this reduction for you. And you can do it with thousands of cases, and 12 or 20 variables. So you'd have the result, W, this should be equals. It occurs if this, or this, or this. So plus would be or. And these are different pathways to getting a good water supply. And here the pathway doesn't necessarily require C, because you might notice that C is a common condition, so it seems like it's necessary in all cases for W to occur. But actually there's one case, it's actually just one row in the table of 19, where C wasn't present, and it was actually irrelevant. So I'm just trying to illustrate that. Another illustration you can look at comes from the study of homicides. So the type of homicide is the outcome, and I think my time is running, yeah, I'm sorry. The slide is going through how fuzzy sets could be used to look at that outcome. But it's quite difficult, isn't it? Because the outcome is inherently a typology. So we instead just crisp sets have been used. But you can use fuzzy sets if the causes are more, if they're more ordinal or have been measured in a continuous way, then you might need it. So for example, whether being young was more likely to make you commit a certain kind of homicide, then one of the X variables might be a fuzzy set. So we find people need to learn about fuzzy sets if they want to be more ambitious in their studies, and yet it becomes a lot trickier to run the systems if you're using fuzzy sets. But it is very scientific. So in this slide, I've just stressed some of the scientific aspects of this work. It's contestable, people can argue over it, and they can replicate. And the data sets are usually available publicly. It's sophisticated, but typically they're based on a qualitative methodology. And so if you have two people arguing and one just fundamentally uses an empiricist methodology, they may find it difficult to concur about what they're even arguing about. For example, error in one and unique deviant cases in the other. So we can argue about subjectivity. But in sociology, we don't mind so much if there is a subjective expert element. That's part of doing science. So I've listed a few papers there. And you know, I promised at the beginning that I would give a summary. Remember I said I'll try and summarize what I was saying about ontology. So I just offer one slide as a summary. That when you set up an analysis, you kind of have your macro, meso, and micro variables. And even cases, there's macro organizations or cultures, there's meso institutions. And so this slide summarizes some of the classic structures, which are macro, some of the classic institutions. This is with reference to criminals. But most experts can work this out for themselves, what the institutions are. Institutions here meaning typical patterns of behavior that are considered normal. And then you record for each case whether it's absent or present. And then finally we get to events, and we record events like treatments and how people act. And that actually is about agency. So I've done some studies like that, and I've found the structural factors quite dominant, but not completely. And it depends really on what you're studying as the outcome. So you get into empirical debates. The resource for all this is a handbook. It's quite an expensive handbook, but from the library you can look at Vernon Reagan's handbook of case-centered research methods. So that has chapters by about 20 different people. So I'd like to conclude and welcome your questions and comments.
Thank you, Wendy. That was
Yeah.
excellent. Thank you for introducing me to a whole host of new terms.